Hello everyone! Are you curious about how radiation on Mars affects humans? Let's explore! The Martian surface presents a formidable challenge for human exploration, with one of the most significant obstacles being the planet's harsh radiation environment. Unlike Earth, which is protected by a robust magnetic field and thick atmosphere, Mars lacks these natural shields, leaving its surface exposed to high levels of cosmic and solar radiation. Understanding the impact of this radiation on human health is crucial for planning future missions to the Red Planet and ensuring the safety of astronauts venturing beyond Earth's protective embrace. Radiation on Mars comes from two primary sources: galactic cosmic rays and solar particle events. Galactic cosmic rays are high-energy particles, mostly protons and atomic nuclei, originating from outside our solar system. They penetrate deep into the Martian atmosphere and can cause damage to living tissue, increasing the risk of cancer and other health effects in humans exposed to them over extended periods. Solar particle events, on the other hand, are bursts of energetic particles emitted by the Sun during solar flares and coronal mass ejections. While less common than galactic cosmic rays, solar particle events can deliver intense doses of radiation in a short amount of time, posing acute risks to astronauts caught in their path. The effects of radiation exposure on the human body are numerous and varied, ranging from acute radiation sickness to long-term health effects like cancer and cardiovascular disease. Acute radiation sickness occurs when the body is exposed to high doses of radiation in a short period, leading to symptoms such as nausea, vomiting, fatigue, and damage to the gastrointestinal tract and bone marrow. While the likelihood of experiencing acute radiation sickness from a single exposure event on Mars is relatively low, the cumulative effects of long-duration missions could still pose significant risks to astronaut health. Long-term exposure to radiation also increases the risk of developing cancer, particularly in organs and tissues that are more sensitive to radiation damage, such as the lungs, thyroid, and gastrointestinal tract. The effects of radiation-induced cancer may not manifest until years or even decades after exposure, making it a significant concern for astronauts on extended missions to Mars and beyond. Additionally, radiation exposure has been linked to other health conditions, including cardiovascular disease, cataracts, and cognitive decline, further underscoring the importance of mitigating radiation risks for long-duration space travel. One of the key challenges in assessing radiation risks on Mars is the variability of the Martian radiation environment. Factors such as solar activity, atmospheric conditions, and geographical location can all influence the levels of radiation experienced by astronauts on the Martian surface. For example, regions closer to the Martian equator may experience higher levels of radiation due to reduced atmospheric shielding, while localized magnetic anomalies could offer temporary reprieves from cosmic rays. Understanding these variations and their potential impact on human health is essential for designing effective radiation shielding strategies and mitigating risks for future Mars missions. Shielding astronauts from radiation on Mars will be paramount for ensuring their safety and well-being during extended stays on the planet's surface. While the Martian atmosphere provides some level of protection from cosmic rays, it is far thinner than Earth's atmosphere and offers limited shielding against radiation. As a result, astronauts living and working on Mars will require additional radiation shielding in their habitats and spacesuits to reduce their exposure to harmful radiation. Several approaches to radiation shielding have been proposed for future Mars missions, ranging from traditional materials like lead and polyethylene to more innovative solutions such as water-filled tanks and regolith-based shelters. Each of these approaches has its advantages and challenges, with factors like mass, cost, and effectiveness playing a critical role in determining their suitability for long-duration space missions. Additionally, advancements in materials science and radiation shielding technologies could lead to the development of more efficient and lightweight shielding solutions tailored specifically for the Martian environment. In addition to physical shielding, other strategies for mitigating radiation risks on Mars include behavioral and pharmaceutical interventions. Behavioral measures, such as limiting the duration of spacewalks and minimizing time spent outside of shielded habitats during periods of elevated radiation, can help reduce astronauts' exposure to harmful radiation. Pharmaceutical interventions, such as radioprotective drugs and antioxidants, may also offer some degree of protection against the effects of radiation, although their long-term efficacy and potential side effects in space are still being studied. Despite the challenges posed by radiation on Mars, the prospect of human exploration and colonization of the Red Planet remains an exciting and achievable goal. By understanding the risks associated with radiation exposure and developing effective mitigation strategies, we can pave the way for safe and sustainable human missions to Mars and beyond. With continued research and innovation, we can ensure that future generations of explorers have the tools and technologies they need to venture boldly into the cosmos and unlock the secrets of the universe. In conclusion, Mars' harsh radiation environment presents significant challenges for human exploration, with potential health risks ranging from acute radiation sickness to long-term cancer and cardiovascular disease. Understanding and mitigating these risks will be essential for the success of future Mars missions and the safety of astronauts traveling to the Red Planet. By developing effective radiation shielding strategies and implementing behavioral and pharmaceutical interventions, we can ensure the well-being of explorers venturing beyond Earth and pave the way for the next chapter in humanity's journey of discovery. Radiation exposure on Mars poses multifaceted challenges that require comprehensive solutions. From understanding the sources of radiation to developing effective shielding strategies and mitigating the health risks for astronauts, addressing this issue is essential for the success of future human missions to the Red Planet. As we continue to push the boundaries of space exploration, our ability to navigate and overcome the hazards of space radiation will be critical for unlocking the full potential of humanity's journey to Mars and beyond. Exploring the vast reaches of space, including destinations like Mars, requires a thorough understanding of the risks posed by radiation exposure. With advancements in technology and ongoing research efforts, we are continually improving our ability to assess and mitigate these risks, laying the groundwork for safe and successful human missions to the Red Planet and beyond. By combining innovative engineering solutions, cutting-edge materials science, and a deep understanding of the biological effects of radiation, we can overcome the challenges of space radiation and open up new frontiers of exploration for future generations. As we look to the future of human space exploration, the lessons learned from studying radiation on Mars will be invaluable for planning missions to other destinations in the solar system and beyond. By leveraging our collective knowledge and expertise, we can ensure that astronauts remain safe and healthy as they venture into the unknown, pushing the boundaries of human exploration and expanding our understanding of the universe. With each new discovery and technological advancement, we move one step closer to fulfilling humanity's destiny as a spacefaring species, boldly exploring the cosmos and unlocking the secrets of the universe. In summary, the radiation environment on Mars poses significant challenges for human exploration, with potential health risks ranging from acute radiation sickness to long-term cancer and cardiovascular disease. However, with careful planning, innovative engineering solutions, and ongoing research efforts, we can mitigate these risks and pave the way for safe and successful human missions to the Red Planet. By addressing the challenges of space radiation head-on, we can unlock new opportunities for exploration and discovery, inspiring future generations to reach for the stars and beyond. Thank you for watching. Please follow for more related videos and see you later. Goodbye.